Hi, my name is Muhammad FAZRUL bin Muhammadin.
Hi, my name is Muhammad HADIF bin FATHELY.
Hi, my name is KHAIRUNISA binti NORHARDI.
Hi, my name is NURAIN WAFIQAH binti DZULQUORNAIN, and we would like to discuss about Ferrocement. Let's go into the introduction.
What is ferrocement? Ferrocement is a type of thin wall reinforced concrete commonly constructed of hydraulic cement mortar reinforced with closely spaced layer of continuous and relatively small wire mesh.
Why ferrocement is used? Ferrocement has an excellent tensile strength due to the presence of reinforcement, making it strong and resistant to breaking and deformation. It can withstand high compressive force and has a long service life. Ferrocement can be molded into various shapes and sizes, making it suitable for a wide range of applications. It can be used in construction for building.
Properties of ferrocement. First, high strength. Ferrocement is known for its high strength to weight ratio, making it an ideal material for structures that need to be strong and lightweight. Flexibility. Ferrocement is highly flexible, which means it can be easily molded into various shapes and sizes. It makes it an ideal material for constructing complex structures such as domes, arches, and shells. Then, fire resistance. Ferrocement is highly resistant to fire, which makes it an ideal material for building fire-resistant structures such as firewalls and fireproof doors. Lastly, eco-friendly. Ferrocement is eco-friendly as it uses less cement than conventional concrete and requires less energy for transportation and construction. It is also easy to recycle at the end of its life cycle.
For constituent materials for ferrocement, the first one is cement, obviously. Usually, ordinary Portland cement is used in the cement mortar mix of ferrocement construction, whereas rapid hardening Portland cement can be used in colder regions. In some cases, the sulfate-resistant Portland cement is used either partly or completely to counter the sulfate attack. The recommended quantity of cement is around 500 to 600 kg per cube meter. Using a lesser quantity of cement will decrease the overall strength and increase permeability. To attain a high-grade impervious mortar, it is necessary to have a clean, good, and well-graded sand. It should not contain any pyrite, sulfate, or chemically active elements that could harmful the mixture. The second one is water. Water is necessary to form a workable mix and facilitate the hardening of concrete through hydration. Utmost care should be taken that the water used for the mixture is potable and free from harmful salts. The cement mortar mix, in the other hand, is a mixture of cement, sand, admixture, and water. Generally, the mix used in the construction of ferrocement has a cement-sand proportion of 1 part of cement to 1.5 to parts of sand. The mixed water-cement ratio has to be as low as possible to have a good workability and quality. Lastly, the steel rods used are 3 to 8 mm thick and their thickness varies accordingly to its location from 6 mm to 20 mm. They are spaced at a distance of 7.5 cm to 12 cm from each other. Lastly, the steel mesh reinforcement is generally made of galvanized steel wires with diameters ranging from 0.5 mm to 1.5 mm and spaced out at a center-to-center distance of 6 mm to 20 mm. The wires are either woven using natural fibers or welded together to form a mesh. The woven mesh has a square opening, whereas the welded wire mesh has a rectangular or hexagonal opening. Expanded metal layer is stiffer and provides better crack control and impact resistance. It cannot be used in structure having sharp curves.
Process of ferrocement. First is easy storage. Ferrocement work requires less storage space for building materials compared to traditional construction sites, which involve large quantities of cement bags, bricks, sand, aggregates, steel reinforcing bars, steel sheets, timber runners, planks, and scaffolding pipes. Weld or wire mesh available in rolled packs can be easily purchased and stored utilizing less space. Next, construction workers. Ferrocement construction requires skilled artisans, including steel bar benders, fabricators, welders, and masons. The fabricated steel bar gauge for a 10 square meter cavity wall weighs only 15 kg and can be easily lifted and erected by 2 persons, making it a cost-effective and efficient method for constructing ferrocement components. Line of reinforcement as per the design requirements. One or more layers of chicken and all-wire or weld mesh reinforcement are decided upon. Binding or tire wires used should be properly cut and bent inwards. It is essential that the wire or weld mesh reinforcement is laid evenly and firmly tied to each other as well as to the skeletal steel, and welding has to be done as per the requirements. The mesh may be made of metallic or other suitable materials. Ferrocement has a very high tensile strength to weight ratio and superior cracking behavior in comparison to conventional reinforced concrete. Unlike conventional concrete, ferrocement reinforcement can be assembled into its final desired shape, and into mortar can be plastered directly in place without the use of a form. Design of cement mortar matrix. The properties of cement mortar mix are influenced by chemical composition, aggregate nature, aggregate cement ratio, and water cement ratio. The mortar matrix is designed for strength, density, and impermeability with workability to minimize voids and map cracking. Mixing with a proper sand, cement, and water cement ratio ensure plasticity and easy casting. The 28-day compression strength for normal weight concrete and steel meshes is 35 MPa, with higher strength desirable for ferrocement structures. Mortar placement or application. Ferrocement construction uses mortar plastering and penetration onto mesh, typically impregnated by hand or spray gun. Merchant lawns develop a layup technique, placing mesh layers in freshly sprayed mortar, proper edge shuttering, mechanical vibration, and cover to mesh enhance durability. Delamination occurs when ferrocement splits, leading to mechanized and precast methods in developed countries. Correct material specification and stringent workmanship are crucial for ferrocement structure failure. Proper curing is necessary to develop the required properties of the mortar. A curing period of 28 days is suggested, however, at least curing in the first 2 weeks is essential and should start 24 hours after final application of the mortar to avoid shrinkage cracks.
Application of ferrocement. Housing and other industrial, commercial, a low-cost dwelling house, strengthening reinforced concrete element, strengthening masonry element. Marine structures such as boat, trailer, barge, floating dock can be constructed with help ferrocement and give better result than steel and wood and a good resistance of atmosphere. Agriculture. The plates that are constructed with the help of ferrocement can be used for construction, for canal, gates over dam, cross drainage work, aqueduct, penstock. Ferrocement lining is a good against abrasive. Anti-corrosive membrane treatment. A ferrocement consists anti-corrosive membrane treatment, hence no other treatment is required to protection against corrosion. The tank container and silos. Every type of tank overhead, underground, or at ground level can be manufactured with the help of ferrocement and give satisfactory service. Floor and roof. We can construct floor and roof various types of buildings, residence, factories, office, and sheds. Waterproofing. By using ferrocement membrane technique, we can construct waterproofing. Manhole drain covers. Heavy duty and light duty manhole cover be constructed and are superior and durable than conventional ones. Wall cupboard. It consists number of small holes in a rectangular form with or without shutters used to store office record factories material. Ferrocement duct. Ferrocement ducts are suitable for circulation of a cool or hot air. Resistant treatment. An overlay of epoxy, bitumen, polyurethane, chlorinated rubbers, lead to lining and glass fibers will be an ideal chemical resistant treatment. Rural application. Ferrocement is applicable in rural areas for construction of cattle sheds, silos for storage of food grains, low-cost houses, community centers, well lining, glow bar gas, and plant lavatory blocks, water storage tank. Elevation treatment. Elevation treatment, such as fins, projection curve, folded and hollow, sunshade to the building, have been provided with advantages. Fire-resistant structure. It can resist fire upon 7,500 for a period of 48 hours. Soil stabilization. Ferrocement can be used for increased bearing capacity of soil for foundation of buildings, bridge and dams. Pipes. There is a corrosion problem using steel and iron pipes instead of these wire ferrocement pipes overcome the problem of corrosion. Sewer line. Ferrocement in sewer line is necessary same as pipes. Bridge. As per now, ferrocement is a crack resistant and corrosion resistant and applicable to make girders plates. Footbridge. Footbridge with ferrocement girders, decking, railing, and roof is better than RCC and steel. Sulfate-resistant cement ceiling. During conventional concrete curing by using sulfate-resistant ferrocement, lining very cost-effective and structures is safe against sulfate attack.
Here are the advantages of ferrocement. Firstly, availability of raw material. Its basic components are commonly found, making it accessible in various regions. And this is the examples of the main raw materials that include cement, sand, water, and a mesh material often composed of layers of fine mesh or chicken wire, sometimes with additional reinforcement like steel bars or fibers. These elements together create the strong and durable ferrocement structure. Versatility in shapes. Its flexibility allows it to be molded into various shapes and sizes, providing design freedom. And this is some example of things that are made using ferrocement. After that, low-skilled labor requirement. While some expertise is undoubtedly beneficial, ferrocement can be learned and applied by individuals without extensive specialized training. This reduces the requirement for highly skilled labor, potentially cutting down our labor costs. Next, cost efficiency. Ferrocement incurs lower construction material costs primarily due to utilization of thinner layers of cement mortar and reduced steel reinforcement, resulting in decreased cement, steel, and aggregate requirement compared to traditional concrete structures. Lastly, enhanced earthquake resistance. The material flexibility and strength make it more resilient to seismic activity compared to certain other construction materials.
Last but not least, these are the disadvantages of ferrocement. First and foremost is labor intensive. Construction using ferrocement can be labor intensive due to the intricate process of layering and ensuring proper reinforcement, which might increase costs. Next is the skilled labor requirement. Skilled labor is required for proper mixing, application, and shaping of the cement mortar, making it more challenging for less experienced workers. On top of that is the susceptibility of cracking with the improper curing or application might lead to cracking, especially in areas with temperatures, fluctuation, or structural movement. Besides that, the surface finish is also a disadvantage because achieving a smooth surface finish can be difficult, requiring additional effort and expertise. Not only that, the corrosion of reinforcement will occur if not properly protected. The metal mesh used in ferrocement can be susceptible to corrosion, especially in aggressive environments like marine settings. In addition, limited structural use could be a disadvantage for ferrocement. Although ferrocement has various applications, it might not be suitable for heavy structural loads or large-scale construction compared to materials like the steel or concrete. Finally, and above all, is a time-consuming process. The intricate process of layering and curing can take longer compared to the traditional construction methods, affecting project timelines. Ferrocement came into the widespread use only in the last 2 decades and still in its infancy. Sufficient design information is available and adequate field experience has been acquired to enable safe design and construction of many types of ferrocement structures. For industrially developed countries, ferrocement seems economical for medium storage tanks, roof shells, boat tanks, and the ease of forming complicated shapes and lighter weight ferrocement can be safely exploited. Alright, that's all from us.
Thank you, sir.
Thank you.
For your time, sir.